In this presentation, we'll explore how to interpret the slope and y-intercept of a line of best fit. These concepts are key to understanding relationships in data and making informed predictions. The table in this example shows how the cost of a flight is related to the distance traveled. This relationship can be modeled by the equation y equals 0.15x plus 24.2, where x is the distance in kilometers and y is the cost in dollars. The technology used to create this equation tries to minimize the distance between the points and the line. These distances between the points and the line are called residuals. The y-intercept is 24.2, which is here on the graph. So the equation predicts that a flight with a distance of 0 kilometers, it doesn't go anywhere, has a cost of $24.20. Notice that this model used distances that range from 350 kilometers to 3,600 kilometers. So making predictions with it outside of this range, like a distance of 0, may produce unrealistic results. There's actually a word for what we call it when a model is used to make predictions outside of the range of the data. It's called extrapolation, and it should only be used with great caution. Now, the slope of the line is 0.15, which means that for every extra kilometer, the predicted cost increases by 15 cents. The model for this line uses a basketball team's ranking to estimate the probability that it wins their first game in the NCAA tournament. The best rank you can get is number 1, so the probability of winning decreases as the rank number increases, because the best team is ranked number 1. Notice that the x-axis is going by ones, and the y-axis is going by tens. So a team ranked number 3 has about a 90% chance of winning their first game. Let's take a closer look at the slope of this line so we can interpret what it's telling us. Let's determine about how much the probability decreases as a team's rank number increases by 1 place. Since we are focused on the line, we need to ignore the dots from the data and identify points on the line itself, because we're looking for the slope of the line. And notice some of these points are not on the line. The 4th ranked team has a probability of winning of about 82%. So that's the point 482. And the 5th ranked team has an estimated probability of winning of 75%. So that would be the point 575. So when we increase the rank by 1 from 4 to 5, the ranking decreased by 7, because 82 minus 75 equals 7. So we can say that the probability of winning decreases by about 7% each time a team's rank number increases by 1 place. This graph shows the number of Americans who viewed the nightly news where T is the number of years since 1980, and V represents the average number of nightly news viewers in millions. So on the x-axis, 0 represents the year 1980, because that's 0 years from 1980. And 30, way over here, represents the year 2010, because 1980 plus 30 equals 2010. Notice that the years on the x-axis are scaled by ones, and the number of viewers is scaled by fives. Let's focus on the y-intercept here. The y-intercept of the graph is here on the line at the point 0, 52. Which tells us that in 1980, 0 years after 1980, about 52 million people watched the nightly news. Let's use that same graph and focus on the slope this time. Since our data goes from 1980 to 2010, let's interpret the slope for this range of years. Remember, we are going to use points that are on the line, not necessarily the actual data points. It's pretty hard to get an accurate reading of how much it changes by going year by year. So let's pick out some good points on the line that will give us better results. Here's a nice clear point at 250, and here's another one at 745. I could have picked any 2 points on the line, but these two were particularly easy to identify precisely. So let's use these 2 points to calculate the slope. All right, so in the first point, we have the first x and the first y. And in the second point, we have the second x and the second y. Now the slope formula tells us to take the second y and subtract the first y in the numerator, and then take the second x and subtract the first x in the denominator. All right, we have all these numbers labeled up here. So we have the second y minus the first y. And we have the second x minus the first x. 45 minus 50, that's negative 5. And 7 minus 2 is positive 5. And we can treat a fraction like a division problem, and negative 5 divided by 5 equals negative 1. So we have a slope of negative 1. So we can say that the number of Americans who viewed the nightly news decreased by about 1 million viewers per year. Notice since we use the word decreased, that was really our negative sign. Households consume more electricity when the weather is warmer. This relationship can be modeled by the equation y equals 0.51x plus 3.19, where x is the average daily temperature in degrees Fahrenheit, and y is the average amount of electricity consumed in kilowatt hours. Let's interpret the slope of this model. According to the equation, the slope is 0.51, which means that, on average, each 1 degree increase in temperature was associated with an increase of 0.051 kilowatt hours of electricity consumption. I hope these examples about interpreting the slope and the y-intercept for a line of best fit on a scatterplot have been helpful. This is Mr. Ela signing off.